All right, hi, this is Michelle doing a video on transformations part 2. So this is like very advanced transformations and end behavior. So let's take a look at this. You would think, looking at this, that it goes right 8, right? So you would think 1, 2, 3, 4, 5, 6, 7, 8. You would think that 8, 0 is a point, and then you'd make your cubic from there, and you do the 2, you do some horizontal compression, whatever. But you would think 8, 0 is a point. Let's check though. X, f of x. Let's substitute in 8. 2 times 8, 16, minus 8 is 8. Cube root of 8 is 2. What? That is not 8, 0. It's not 8, 0. What is happening? So if I want 0 as an output, clearly I can't put in 8. What could I put in for x to get 0 as an output? Let's try 4. Let's substitute in 4. 2 times 4, 8. 8 minus 8, 0, cube root of 0, 0. Yeah, so actually my center is not at 8, 0. It's at 4, 0, which is a little bit crazy because it goes right 4. Whoa, why does it go right 4 and not 8? Let's, and then you would make a table from here. You'd make a graph from here. So instead of going up 1, right 1, this 2 is going to change the x value, right? It's going to change the horizontalness of it. And is it going to make it horizontally longer or horizontally shorter? Like smushed horizontally. It's going to make it horizontally smushed. So instead of over 1, up 1, I'm going over a half, up 1. That's what that 2 does. So everything that is done to the horizontal, to the x is sort of backwards. So even though it's a 2, you go over a half, not 2. So all the horizontal transformations, remember, are sort of backwards. So I go over a half. And then I'm just going to sketch it. I could plug in more points to see. Something like that. But those are my 3 key points that are good enough. So what do I notice? I notice the center is at 4, 0, not 8, 0. So it doesn't go right 8 is what I noticed. I noticed it going right 4. So the question is, going forward, how do I not mess up and say like, oh my gosh, right 8? How do I know that it's going right 4? And where do I get that 4 from? So let's flip and see. Yep. I want to do this. These are backwards. I want to do wrench. We'll change this to 2. All right, so here, consider f of x equals absolute value of 5x minus 10. So the vertex of this, where do you suppose it'll be? Instead of write 10, here's my strategy. I'm going to set the inside equal to 0 because my key point for an absolute value, luckily, so far, my key point, every key point for every parent function I know has an output of 0. So I want to figure out what makes my output 0. Okay, so that is my strategy. So add 10 to both sides, divide by 5, 2. So my vertex is in fact at 2, 0, not 10, 0. Poink. Let's just check this and make sure. Do you see how if I plug in 2, I get 0 as an output? This makes sense. So this strategy of the inside equaling 0 tells you my x value of my vertex. Another option is you could get it by factoring. So if I rewrite, option B is rewrite inside by factoring. Rewrite inside by factoring. So you probably notice that this 5, you can factor it out. Little 5 parentheses, x minus 2. So if it's in factored form, you can easily see from transformations that it's right 2. So this, see how it's right 2? Okay. So I'm going to go over a fifth. Okay, so now to finish the graph, it basically is a slope of 5. 1, 2, 3, 4, 5, 1. So you can think of it as over a fifth up 1. if you want to think of it in terms of a horizontal compression. With absolute values, I know you guys are really strong at graphing lines, so I just think of it as a slope of 5. But really, it's like it's on the inside, so it's compressing horizontally. It's making the horizontal go over just a fifth. Okay. Alrighty, so those are our two strategies, inside equals 0, rewrite by factoring. So let's look at this one. We'll change this to part 3 here. Great. So you would look at this, a minus 3 in the parentheses goes right. Let's see though. So if I go right 3, but see how if I plug in a 3, I don't get 0 out? So if I set my inside equal to 0, I will find my vertex of this parabola. So I'm going to add 3 to both sides. Negative x equals positive 3. X equals divide by negative 1 on both sides. X equals negative 3. So in fact, this goes, the vertex is at negative 3. Okay. Our other option would be to factor. So if I factor, this would be x. So what would be in the parentheses? If I factored out a negative here, the negative x would become x, right? And the minus 3 would become just a 3. So plus 3. So if you factor out, you can see that it goes left 3. Okay. So either way that works for you, you can use either technique. So this is a reflection. It changes the x value, so it's a reflection across the y-axis. When you take a parabola and reverse all the x's / reflect it across the y, it's the same thing. So I'm just going to graph it like a regular parabola. I have 1, 1, and then I go over 2, up 4. Okay. But you have to do either one of these, okay? You might have learned if there's a negative in front, you could just do a trick. If there's a negative in front, it works opposite, but this is the explanation of why. And you can always, again, if you're not sure, you can always just plug in a point. So we have negative 3, 0 as a point. If I plug negative 3 in, do I get 0? Yes. So you can always just check your work. All right, number 4, try it on your own. I want you to tell me the center of this cubic. It's going to be at something, comma, 0. Something, comma, 0. So I'm going to set my inside equal to 0. And I get 2. I could also factor out. Factoring out can be a little bit tricky because you have to use double parentheses. So x minus 2 cubed. Okay. So either way, I know my center is at 2. Or if I factor out, I see that I go right 2. Okay. And that this is a 3 inside the parentheses, so it's a horizontal change, and I go like over a third, basically, instead of over 1. And this negative switches, so let's figure out this negative again. It's a reflection across, I'm gonna look at my parent function of my cubic. Here's my parent function of my cubic. So if I reflect this across, if I change the x values, because inside changes the x, so it's a reflection across the y, okay, it does reverse. So I'm going to do it like over a third, like left a third, up 1, right a third, down 1, to make it look backwards. If I want another point, this is good. 3 key points is solid. I just want to focus on this wrench for now. Alrighty, so when you look at this, it goes right 2. It's a little bit crazy. But that, if you think of it, 2 is what you'd have to plug into the inside to make the output 0. All right, totally switching gears. We're going to talk about end behavior. This is something we'll talk about more. So this is a review from Algebra 2. You should have learned it fully and remember it, but just in case, we're going to go over it again. All right, so describe what, here's what end behavior is. Describe what the x value does as the absolute value of x increases. Okay, that's what end behavior is. You're thinking as x, so as x heads towards infinity, what does f of x head toward? So that's how you write an absolute, and then we're gonna figure this out, but that's how you always write absolute end behavior. So let's look at this table. So as x is heading towards infinity, right? So I have 10, 100, 1,000, 10,000. X is heading towards infinity. Y, you have 0, negative 2,000, negative 2 million, et cetera, is heading, it's just getting bigger and bigger and bigger, but negative. So really like smaller and smaller and smaller. So negative, it's heading toward negative infinity. Okay, so that's one side of the end behavior. That's as x approaches positive infinity, but I need to do the other side as well. As x approaches negative infinity, f of x approaches, so let's read it the other way. Negative 10, negative 100, so right this way, okay? X is approaching negative infinity. F of x is approaching, so 2,000, 2 million, this is actually positive infinity. My numbers are getting larger and larger. So here I'm heading toward negative infinity, here I'm heading towards positive infinity. Okay. There we go, let's flip. Let's flippy flip flip. Okay, we're gonna do this in a sec, but let's examine this. So we just did a table, I wanna look at it graphically now. So there's 4 cases total for polynomial end behavior. So x squared, as x is heading towards positive infinity, so as you're going to the right, the y is heading up and up and up and up, so toward positive infinity. See how that's like a tiny little positive infinity there? So as for if you have a positive coefficient of an even function, this will always be true. Let's look at this one. As x, it's the same function, but as x is approaching negative infinity, so I'm going left, my y is going up without bound, so towards positive infinity. So just take a second and look at this. So here, if you have a negative in front of a even function, the right side is going down towards infinity and the left side going down towards infinity. So that's why I have p of x heading towards negative infinity on both end behaviors. Just as an aside, so polynomials always increase or decrease without bound as their end behavior. So for polynomials, for now, you're always going to head towards positive or negative infinity. We'll see other examples, asymptotic examples, where you're going to head toward a number or toward, a number that could be 0 or 2 or something. But for now, we're just considering polynomials, and so they'll always be decreasing towards infinity or increasing towards infinity. So in odd, you can see how the right side goes up, so that's positive infinity, and as x approaches negative infinity, p of x approaches negative infinity. You can see it going down. And this is the reverse. All right, so let's do our final example here. Then we'll practice more in class. But describe what the y value does as the absolute value of x increases. So here's your example. F of x equals x cubed plus x squared minus x plus 5. So I'm going to set us up, and then we're going to actually consider this function. So as x is approaching positive infinity, and this function's name is f of x, so f of x is approaching. All right, I'm going to leave that blank for now for you to fill out. And here, I'm also going to do, as x approaches negative infinity, f of x approaches what? So you can think of this, this has lots of different parts. When x is approaching infinity, it's only the largest exponent that's going to dominate the behavior. The largest exponent will dominate the end behavior. So you actually only have to pay attention to largest exponent and its coefficient. Largest, like the term with the highest degree. Okay. These other terms will matter, but as x approaches infinity, they'll matter less and less, and to the point where they're insignificant. Okay, so this is a cubic. You can do it numerically or graphically, like the n or the g. I'll do it graphically. Okay, so I got a cubic. As x is approaching infinity, y is approaching, fill that out. It's going up and up and up, so infinity. Okay. As x is approaching negative infinity, okay, so as I'm going left on my function, so see how I'm starting in the middle, but I'm going left and left and left, what are my y values doing? You're going down and down and down, infinitely far down, negative infinity. If you wanted to do it numerically, you could plug in like 100 cubed would be a very big positive number, which symbolizes infinity for us. This would be negative 100 cubed. So I'm just pretending 100 represents an extremely large number, like we're approaching infinity. Negative 100 cubed would be like negative a very large number. So that's going to represent negative infinity for us. But you see, if you cube a negative, you get a negative output. That's why in this case they match, but they don't always match. All right, thanks for doing this video, and I will see you soon for class. Bye.